The reason that we breathe is to exchange oxygen with the environment, and of course we need oxygen in order to survive. But what most people may not think about is the CO2 that is being produced by our body also needs to be exchanged with the environment. It's really a two-way street, the inflow of oxygen into the lungs and the removal of CO2 from the lungs. The research that we're working on right now is developing a breathing system that allows us to control the levels of oxygen and CO2 within the lung. And by controlling the amount of oxygen and CO2 that you breathe in, we're able to control the amount of oxygen and CO2 that is contained within the blood. And this is important because the gases that are within the blood are responsible for controlling your breathing rate and volume, as well as controlling blood flow to your brain, for example. So if CO2 is increasing, blood flow to your brain will increase. If CO2 decreases, blood flow to the brain will decrease. And this is to help maintain the acid-base balance within the brain tissue. That's what we call cerebrovascular reactivity when we assess the magnitude of that response. And that provides us with information about the health of the vasculature within the brain. So if the response is large, it might suggest that the vascular health is good. If the response is small, it might suggest that there's vascular disease present within those vessels.
I did my undergrad in Calgary, and I came to Kelowna wanting to work with this specific research group just because what they're doing and what they have been doing over the past few years has been incredible.
Because of the expertise contained within the Center for Heart, Lung and Vascular Health here, we have access to a variety of researchers that are A, capable of controlling arterial blood gases, and B, capable of measuring cerebral blood flow responses by a variety of different methods. And so by having these two features in place, we're able to assess these responses in a very controlled experimental setup.
My research is focusing on using a particular method in order to alter arterial carbon dioxide and arterial oxygen within the blood. And this relates back to Dr. Foster's research grant that he just won, which has enabled us to pursue this project.
The NSERC Engage grant that I received was to collaborate with a company from Toronto called Thornhill Research. And Thornhill is involved in the development of breathing apparatuses that help to control arterial blood gases, similar to the device that we have here. And so we've combined forces to try and improve how these devices work for the future so that we can use them to assess vascular reactivity, typically in the MRI clinic. Other uses may be in high-risk environments. Military, aeronautical staff may be able to use this type of a system to control the blood gas levels of oxygen and CO2. I hope that this research will help to improve our assessment of vascular reactivity such that we can determine people at risk for vascular disease and prophylactically treat them for their issues before the vascular disease becomes too far gone that we can no longer treat it.